Okay. Hello and welcome to everyone in classrooms and at home around the country to our STEM and STEAM Day celebration on the EF virtual stage, featuring our good friend Khalif from MassRobotics, which is one of our amazing exclusive partners in the Boston Seaport that helps our Boston STEM discovery tours truly come alive. Khalif will tell you a lot more about the incredible things that are happening down there and his awesome role in just a few minutes. My name is Darby, and I help to support our educational partnerships at EF. And I'm joined by my awesome colleague, Kate, who oversees our entire STEM portfolio of tours and will be monitoring the Q&A feature in the chat. So please ask questions if you have them throughout. We would love to hear from you and should be able to address those at the end. And so with that said, happy National STEM and STEAM Day to everyone in Khalif. Thank you so very much for being with all of us today. And we will flip this over your way.
All right. So, hello, everybody. I'm Khalif. I run the education programs at MassRobotics. And so first thing I want to do is just introduce you guys to what MassRobotics is, and what is our role in the robotics space. So we're MassRobotics is a nonprofit organization, and our goal is to kind of elevate the robotics industry and the tech world. And so we do that from a couple different angles. The first one is we have a facility here in the Seaport. And in this facility, we have a bunch of different startups that are at different levels. Some are just have a prototype. Some of them are trying to make, they're trying to productize what they have. Some are in some level of developing new application of technology, but they're all working on something in the robotic space. And so our goal is to kind of get them into the market, get them exposure so that they can actually continue to support the robotics industry. Then we have the corporate side. So these are your big robotics companies or other companies that have a robotics element or are more curious about the future of robotics. And so these are companies like iRobot, Amazon Robotics, but also companies that maybe you don't think of as being robotic, like FedEx, what's another really, AMD, right? So AMD makes graphics cards, but that same technology is very useful in robotics technology because they make processes, right? So because they have an application in robotics, they're interested in knowing what is going on in the startup world, what's going on at the innovation level of robotics. So we provide that for them. We also do a lot of weird things with the government. So we educate government on what is necessary in order to give robotics a space in everyday life, from delivery robots to testing facilities, et cetera. And all of those different elements support the education side, which is what I do at MassRobotics, and it's why you guys are here today. So before I go any further, I want to give us a baseline. When I talk about robots, I want us to all be thinking about the same thing, right? Because there's a lot of technology out there. There's a lot that we kind of are used to, that we've come to know as another piece of ourselves, like our phones, right? But robots have a special place because of how we interact with them. And so whenever we talk about robots, we're talking about technology that has some kind of sensing element. So I have a basic depth camera here, which is one of the types of sensors that a lot of robots have, along with cameras and LiDAR technology, which is like laser radar, and all sorts of other types of sensors that robots use to get a feel for their environment, so they understand what's happening around them. And then they all have some kind of computing element. So that's, your computer or just electrical circuits that allow it to get in some input from the outside and convert that into some usable data. And then there's the movement element, the actuation, which is, the moving arms and things that it actually uses to affect its environment. Those three elements, right? Actuation, sensing, computing, all working together, that's a robot. And that's what makes it really special, is that we interact with robots in the 3D environment in our normal everyday world. And that's unlike any other piece of technology, right? You interact with your phone, but your phone does not interact with you the same way, right? And it's more than just like a software relationship. This is, imagine if your phone, when you couldn't find your phone just flies over to you. Again, not a thing which is probably gonna happen, right? But that's kind of the difference in interactivity, right? When something can interact with you in this 3D environment. Oh, goodness. That got me too. That's So this is Pepper. Pepper is one of the many robots that we show when people come in here. She's doing her startup animation right now. So you'll see her kind of stretching, moving around, right? And Pepper is what you think of when you think robot. You think humanoid, it looks kind of human. It has some basic interactions, right? But robots go a lot further than just kind of that humanoid model that we think of. In the manufacturing and warehousing space, we see a lot of things like Baxter over here. Good, Pepper? All set? Cool. I'm just gonna mute you. Perfect. All right. So Baxter, you'll see a lot in kind of conveyor belt style pick and place. And Baxter is a collaborative robot. Collaborative robots have become a thing in the robotics industry because they are safe to work around people as opposed to your big manufacturing arms that you think of maybe in an automotive industry, right? And so those robots are very expensive and they are very dangerous. So they're kept in cages, so people can't really get in there because they move too fast and don't know you're there. So don't want to be around them. These guys, on the other hand, right? Is it this arm? That's the one. All right, cool. So these ones have safety features. So if I, just bump up against one of the arms, it'll completely stop, right? Because it understands there's something there. I need to make sure I don't hurt it. And that was one of the first things that needed to happen in order for us to be able to have a more direct working relationship with these kinds of robots. The other piece we needed was a better way to train them. So right now, with most robotics, you need to have someone who is good at software, who can program away and figure out all the different kind of interactions the robot needs in advance. But in many situations, you need something that can kind of do different things on the fly, either because the person doesn't know the best way to utilize the tech yet, or because the nature of the work involves a lot of shifting movement. So we would prefer someone who was had less knowledge of the software itself, right, could actually program the robot. So with Baxter, you can kind of train it to do a motion and it will repeat that motion exactly. So I'm gonna have it grab this cup. Wait for a second, I'm just gonna drop the cup. I'll remember this time. Last time I did not remember, I was gonna drop it and then return to a normal position. And if I replay that, it resets and then does the exact same motion all over again. And you can train someone to do that very quickly. And this is one of those things that has just made robots a lot more accessible than it has been in the past, right? There it is. So now we're starting to see robots all over the place. One of the benefits of this is that now companies can focus in a little bit more. So like I said, we have a lot of different companies here that do a lot of different things. But a key feature is very few of them are making the entire robot. Robots, in order to make robots, you need to have all these different elements of engineering. And once the industry gets big enough, now people can focus in on certain things. So there are companies that make just these grippers here. And these grippers are called end effectors because they go on the end of robotic arms, like Baxter over here, or like the Sawyer robot here. And each gripper has different purposes, right, for grabbing different kinds of objects. As you saw with Baxter, Baxter has one of these kind of mechanical grippers. It just goes in and out like that. Very good for holding structurally stable objects, right? So this cup right here, plastic cup, you can't really crease it at all. It's very stable. And also in that demonstration, I knew exactly where the cup was going to get placed. So it's very easy to make this gripper pick up this cup when I knew what it was, where it was, and it was the right type of object. But sometimes we need something a little more flexible because we may not know what we're picking up. We may not know where we're going to pick it up from. We may not know from what angle we're going to pick it up. So we have something like this, right? Or something that's too fragile, right? So this is a soft gripper. This is from a company called what is it? Soft Robotics? Yeah, but they make soft grippers, just like this. And this style of gripper is very good for picking up more fragile things. Like say, for instance, a bag of chips. If you try to pick up a couple bags of chips with this kind of mechanical gripper, you're just going to get a lot of crunch, right? And we don't want that crunch when we're dealing with chips. You want your chips to come kind of full and not crumbles, right? And so similarly with something like this also is just it's going to crunch up the chip something fierce. So we might use something like a soft gripper. You can see this rubbery, these rubbery fingers. It's controlled with air pressure. So the air pressure comes in and sucks these fingers together just like that. Very good for fragile objects or something like a fish, right? So we had a research project where pick up fish with that particular gripper. And you could pick it up from the tail or pick it up from the head or the body, and you weren't going to smush it, which is always very nice when you're dealing with something fragile like that. And then we have stuff like this. Hard to see from here, but this is a vacuum gripper, right? Has a little suction cup. I have a bigger version of that on this robot over here. I'm going to demonstrate really quickly how exactly that works. All right, so I turned on an air compressor that's pulling air through this this robot here. Now, if we want to pick up that same bag of chips, push it up against that, just like that. Now we're holding a bag of chips. No crunch, no nothing. Chips are all whole. And it's actually pretty strong. I can pick up my phone with it. So if I check my phone on that, I trust the robot to not drop my phone, right? So these kind of grippers are very versatile. And that's a very common use case in the robotics world. One of the things that I like to do when we are showing students around the MassRobotics space and showing them all these different types of robots is kind of connect that back and say, all right, so these are all, fully developed robots. You can't see a lot of the insides. You don't really understand what's going on, right? But it's my job to kind of get you to see that this is actually not as complicated as it might seem. Really what we're looking at is a combination of a lot of very simple steps that over time you learn to understand and can kind of see the bigger picture of how the technology actually functions. So we work with FIRST. FIRST is the largest robotics competition provider in the world. And they have a variety of different competitions, such as the robot this is from FTC. And this is one of the things that we teach at MassRobotics when EF groups come through. And the thing I mean, besides the fact that, you get to program this, get to, drive it around, figure out how to do different types of actions with it, just understanding how it works will go such a long way, right? It's always looking for the same elements. I talked before about some kind of moving element, right? So we have the wheels, we have the arm, we have the gripper here, right? Talk about some kind of computing element. That's all in here. This whole thing is a control hub that controls all these different things. And then some kind of sensing element. And you can see there's a little sensor down here, right? Basic color sensor. And just by understanding that, okay, all these things connect into the control hub, right? All of them connect into the control hub. The motors for the arm and the gripper connects to the control hub, and they're all labeled so you can see it going on there. Then you just have power. And that's exactly how every robot around here works. They have a bunch of different parts that a data connection to the control hub and a power connection to the power. And it's the same exact thing that's happening. Oh boy, this is heavy. It's something like this. So this is the interior computer of that robot right over there, right? That Sawyer robot, same exact thing. And it looks very complicated, there's a lot going on there. But really all we're seeing, I need to drop this a little bit. There's a computer section right here. It's just a normal desktop computer with all the kind of normal computery type things. And then you just have this section. And all in this section, if we really looked into it, we see motor drivers, which are the same things that we see in the control hub, right? And you can follow the connections to all the different sections of the robot. And that's all that's going on. All that's going on is things are connecting from one place going to another place, and we can teach how that works. And then you start to see But this same technology is all over the place, right? So, with robots, we see a lot of, when we think about robots, we see a lot of these humanoid robots. We see a bunch of these kind of arm robots, but really robots span much wider than we normally conceive of. So drones have become a huge thing in robotics. We have a bunch of companies that work with either drone hardware or drone software that are trying to do different kind of innovations in that space. And we start to see them in filmmaking, right? There's a lot of filmmaking that happens with these drones. All of those are robots, right? Modern cars are in many ways robots. I'm not even just talking about a fully autonomous Tesla car, right? A normal car, just a modern car often has cruise control, lane assist, keeps you make sure that you're in the right lane, right? Automatic braking, automatic parking features. All of these are different robotic elements that we're starting to see in all of these normal everyday activities. And I challenge you, you can find them all over the place, right? There are all these things, the world is sensing stuff around it, right? And it's reacting to it. And that's all what we talk about here. What was the last point I had? One more point. So I briefly wanted to talk about kind of like how I got to this point, because I can talk about like all this stuff very casually now. I've realized over time that this has become kind of my normal. My normal is surrounded by robots just like this. These are extra robots that we brought just to show you guys, right? Behind me, there are bigger robots. There are more varieties of robots. I mean, robots are in every industry you can think of, from manufacturing, agriculture, sea robotics, blue robotics, right? It's a big emerging field. So there's underwater robots and stuff like that. And now I'm very used to it. But I started same place that most students start. Just I didn't have a robotics background. I didn't have a computer science background until I hit late high school. And then I joined the robotics club and got to kind of fiddle around a little bit. We had a competition. We were never very good. It didn't really matter because we're just learning as we're going. And I brought that same thing, that same passion for technology. I got to teach the younger students as I became older and got to show the new students in the club. And that became a teaching career about technology, which led me to MassRobotics and kind of building up the STEM stuff that we have going on around here. And yeah, there's nothing more liberating than understanding that all the technology that you see around you is stuff you fully understand. And if you don't understand it now, you can take it apart, read up on it, and all of this stuff becomes clear as day, and you can see how every little thing works and how they're made. Very fascinating. And I'd love to show you all when you come in.
Awesome, Khalif. Fantastic presentation. But I do have to say, I think Pepper has stolen the show here. So I do want to ask a question about her quickly. Can you talk a little bit about what her purpose was, what she is designed for, and if certain aspects of her, software or hardware could potentially be applicable for future robotics innovations?
Right. So Pepper is extra special. Let's see if I can get Pepper to notice my face. Come this way. There it is. See? So Pepper's main quality actually is looking kind of human-like, right? What's blocking your view of Pepper? It's this thing. Ooh, there it is. So you can see Pepper has arms, face, eyes, a lot of these things you can recognize as human qualities. And what that does is when people see Pepper, like you said, really steals the show. And so wherever you put Pepper, unlike a lot of robots that people kind of look at from afar and be like, oh, that's interesting, but they'll look at from over here. People approach Pepper and you expect Pepper to interact with you, right? And Pepper's kind of in a no interaction mode at the moment, but Pepper can give you fist bumps. She can tell you about herself. There's I could start up all these different programs that do all these different types of things. And the only reason that people do that is because as humans, we like things that kind of look like humans. And so a lot of the humanoid robotic space is made for greeters. So think museums, schools, right? Any situation where you would need to invite people into a space or you want to excite people about some of the stuff you have going on. greeting is a, robots like Pepper tend to be humanoid in some way, shape, or form. Now, the humanoid form is kind of difficult to deal with. So there are some limitations. In fact, Pepper doesn't have legs. She has like a waist and it goes to wheels, because getting that balance right, very, very difficult. And it's not until recently with kind of what Boston Dynamics does. I mean, if any of you haven't seen, just search Boston Dynamics parkour. I guarantee you will make your day, right? They have fully humanoid robots with legs and everything that can do flips and stuff, literal flips, and run around and do all these kind of things. Absolutely incredible to know that we're in an age where this is possible, but they're cutting edge, and they've been researching this kind of technology for the last 30 years. Pepper, much simpler than that, right? So we're not quite to that full humanoid level yet, but the main benefit of the humanoid form is one, in approachability, so people are very comfortable with it, and the other one is one of flexibility. Here we have just arms, right? And they don't look like human arms because we wanted some extra degrees of motion there, right? But they are just arms. And so if we wanted this same robot to go and do something like to move somewhere, it can't move anywhere. If we put wheels on it, we can get it to move to some locations, but not others, can't go upstairs. The humanoid form is very variable, right? So mastery over figuring out how all this works and how we can make a robot do the same things means we can just enter different spaces that we currently can't with most robots.
Awesome. Yeah, on that sort of vein of thought, you'd mentioned that you got into robotics, I guess, in sort of later high school. Was there like a portrayal of robots in media, in movies, TV show that sort of started to get you excited about robotics?
It wasn't so much a media portrayal. Like, I mean, I think the first robots that really stuck in my mind as robots was in the movie I, Robot. Go figure. With my dad was a big science fiction reader, and so we watched the movie and we're like, oh, Will Smith, yay, robots. And then he was like, well, you should read the books, which leads into a whole series of ethical dilemmas of fully sentient robotic thought. And that, again, that was just a thing. Honestly, the real thing that got me into robots in the first place, it wasn't any media portrayal. It was just at school, I had friends I hung out with, and some of them were like, hey, you should join the robotics club. You seem like you'd like it. I was like, sure. And then I did. And I did like it, right? And that's I'm here because of some random conversation when I was a sophomore in high school. Like, it's crazy to think, man, I actually hadn't thought about that before. What a strange series of events that leads me to talking to you guys here.
Yeah, we're pretty lucky that your friends pushed you in that direction, I have to say. Obviously, there are other people who sort of kept you focused on that direction. Could you talk about maybe some of the teachers or the mentors that you worked with who supported your journey in STEM and supported your journey in robotics?
So whenever I hear like a question about influential teachers, especially when it comes to the work I currently do, I always think of the same two teachers. And the first one was my computer science teacher in high school. And he actually, not only did he kind of set me on the path for understanding technology at just a higher level, also he introduced me to the college I went to, which is WPI in Worcester, a school I had never heard of before. When you think tech school, you think like, oh, MIT. I'd just love to go to MIT. That would be great. Or I would love to go to. I wanted to go to Carnegie Mellon for a while, right? Those were the schools. And then it's like, yeah, but like, check out Worcester Polytech. And just knowing where he came from in his journey, like, that's where I ended up going. It was a fantastic fit. But he kind of introduced me to, the technology, how it works at a very basic level. But his excitement for it is really what kind of got me to the next level. Because, I mean, engineering is a weird discipline. It's a very strange discipline. There's a lot of thought processes that are not your everyday. You have to really think like a machine in many ways in order to kind of get things to work properly. Because they don't assume anything, they don't understand anything until you give them that understanding. And he was able to really lead me through that to kind of get me to that next level. And the other teacher I bring up is not a technology teacher at all. He was my art teacher. And he taught me a larger life lesson that just happened to be very applicable to engineering in general. So I was struggling. This was senior year of high school. I was struggling to. I had to make an oil painting, and I was trying very hard. I kept hating what I did. I was like, "Oh, this is terrible." Rip it up, throw it out, and I did that for weeks. And one week he sat me down and was like, "All right, we're done with that. You're gonna keep working on this one until it's done." And I would do something and I'd be like, it's bad. I just want to move on. They'll do a new one. He was like, "Nope, keep working on it. Keep adding," right? So add another layer, add another element. It kept going and going and going and pushing through the like, "Oh, this is not working at all. It looks terrible." Pushing through that. It ultimately led to one of my favorite pieces that my sister has in her new house. And, she loves the piece, which is the best thing for an artist, really, is when someone else likes what you did. But that one, the picture of a flower pot with some sunflowers in it. That's all it was. But pushing through that and him getting me to push through all those levels that's just engineering. That's just what all this is. It's just a bunch of until you finish it, nothing works, right? Now, if we take something, for example, until this is fully built, you try and turn it on, it doesn't work. You don't know why. So you add some stuff, right? You try connection in a different location. You say, "Did that work?" You try it, doesn't work. All right, and you keep going through that process. Keep figuring out what are the steps I can take to get something to go right. And as you keep going through that, I mean, eventually you get to some of the complicated stuff we see around us. Because just like I was saying, it's all adding things on top of other things until it works the way you want it to work. And so without that lesson, I probably would have gotten too frustrated to continue down a technology path in general.
No, I think that's a great lesson. And I hear too from friends who are, computer programmers, like when they have a bug in the code or this or that, it can be incredibly frustrating.
Oh,
Um,
computer coding bugs are the most fun, because you think the whole time it's like, I did something wrong, right? I did something wrong. And then it turns out you put like a period out of place somewhere or parentheses, and that was the thing, which is, it's a glorious feeling. And also you're like, I spent 2 hours looking for that little, but it works. There's nothing quite like the feeling of something just working. Oh, it's magical.
Absolutely. On the converse, how would you advise people to proceed when things aren't working? Obviously, failure is part of a learning process, both as a STEM person and as a teacher. I'm sure you encounter that a lot. What are some tips for maybe any students we have on the call who have dealt with that and at times feel discouraged?
Number one tip is that is just things not working. That's just normal. That's just how all of this works. All these companies that work in our space experience failure on a quite literal hour basis, right? What they're trying to do here is trying to make a technology that works, and then again, until it works, it just fails over and over and over again, and it often fails at the exact worst timing. And that's a feeling and a process which, once you start to understand where it will head and that you can get it there, it just becomes part of your normal, right? So we have these big days where we bring in a bunch of companies and a bunch of heads of companies and funders and investors that want to invest in all the different companies we have here. And when I say we have people coming, I mean like list of guests, CEO of iRobot, Amazon Robotics, Secretary of Labor for the country, right? That's like the stakes we have here. And then we have our startups of people that are maybe fresh out of college trying to show off their technology. And frequently what happens is, we prep, everything's there, it's all working, and then they go to present and nothing's working. And so what we see from the outside is, did it work? And then they just keep talking, and they're just like plugging things in and restarting things and just dealing with the problem as it happens, as they're trying to impress all these people. Because that's their normal every day. Like, something not working is not it's not even a huge surprise. It's just figured it would stop working right here. It's okay. We'll just keep going. But they know exactly the steps they would need to take in order to fix it. And that's what the education's for, just to get you to have the confidence to know, I know what the next step is. I know what the next thing I can do is. And so if you just focus on that, just know you're going to get it. Just got to keep trying things until it works. Eventually, that becomes the joy of it. You thrive in that feeling.
I love it, Cleve. I'm going to bounce in. I know that we're just about out of time, but I think this notion of resilience and leaning into failure is such a good one because it is a part of the process. And I just think it's wise words and a great lesson from you, Khalif. And you're awesome. So thank you so much for being with us today. Thank you also to everyone in schools and at home for joining us as well. We hope this was enlightening and that you learned a lot. I know I did. There is a brief survey that will pop up when the event closes. So if you could just take a few minutes and give us some feedback, that would be terrific. Thank you to everyone at MassRobotics for this like amazing, rewarding partnership that we have. Kate, of course, for being such a great co-pilot and moderator. And everyone have a great STEM and STEAM day. And thank you for joining us. Khalif, thanks again. It was awesome.
Cool.
All right. Great to see everyone. Bye-bye.